So good morning, everybody. Yesterday in class, the last thing that we mentioned was how do we deal with alkane structures that have multiple functional groups that are not the same. Remember, when it comes to this, we always have to identify the longest carbon chain. That's the number one rule. Then after that, we're going to start numbering from the end that is closest to a substituent. After we have done that, the last word in our naming is the name of that parent chain, alkane. Then as a prefix of that, we're going to give the location and the names for the substituents. And we have to remember that we have to place them in alphabetical order. So today we are going to start talking about what about if we have alkanes that are cyclic. Cycloalkanes are going to be structures that have 2 fewer hydrogen atoms compared to the open chain alkanes. What that means is that cycloalkanes have the general formula of CnH2n, okay? Where N starts at 3 and then it continues onto any number of cyclic structures. Now, in the problems that I have in the in-class worksheet and some of the ones that we have here, we are going to have cyclic structures up to 10 carbon atoms in length. Now, it is important to note that whenever we have these cyclic alkanes, they are actually going to adopt geometric figures. So the smallest cyclic alkane that we have, as you can see here, is the one that looks like a triangle, okay? So its chemical formula means that if there are 3 carbons, and that's what N equals, it is C3H6, its chemical formula. And if we look closely at it, it has 3 carbons and 6 hydrogens. So that's where the CnH2n comes from. Now, when it comes to naming these cyclic structures or the cyclic alkanes, as you can see, we're going to include the prefix cyclo. So, for example, here we don't have the names of these cyclic alkanes, but for the first one, it has 3 carbon atoms. So the name of this one is going to be cyclopropane. Because again, cyclo because it's cyclic, prop because we have 3 carbons, ane because it is an alkane. Okay, let's put it in the chat. What do you guys think is going to be the name for the cyclic 4-carbon cycloalkane? What would be the name for the cyclic 4-carbon? Great job, you guys. This is cyclobutane. What about the one that looks like a pentagon? What would be the name? Great, this is cyclopentane. And as you can see, the skeletal structures are given in that second row. Lastly, we have something that looks like a hexagon. What would be the name of that? Great job in the chat. Cyclohexane. And you can imagine if we're going to go into cyclic systems from 3 to 10 is going to be cycloheptane, cyclooctane, cyclononane, cyclodecane. Okay? So As you can see, these are the names for some selected number of cycloalkanes. But like I said, the smallest cycloalkane is going to have 3 carbon atoms. The largest that you guys will see in my course is going to have 10 carbons in length. So let's now learn how to name cyclic alkanes, okay, depending on the number of substituents that they have. Starting with, what about if we have a cyclic alkane with 1 substituent? If we have a cyclic alkane with 1 substituent, what you guys need to do is name the substituent, and you use that as a prefix of the cycloalkane name, okay? So if we have the following example, what would you guys think is the name of the example that we have there? Great job. This is bromo, cyclopentane. Let's move on to the next one, which is when we have 2 substituents in my cycloalkane. You're going to number the ring clockwise or counterclockwise, okay? Because it depends where the substituents are inside the ring, which direction you're going to take. But the most important thing is that you're going to number the carbon atom in the ring that has the substituent with the lowest alphabetical order, okay? And then that carbon that is holding that substituent in the ring is going to be carbon 1. Then you're going to, again, number the rest of the ring, clockwise or counterclockwise, to just give location to the other substituents, but you want to make sure that they have the lowest number. So when it comes to the example that we had here, what is the name of the substituent that I'm highlighting in pink? Ooh, somebody's ahead. Yes, that's methyl. Great job, Francisco. That's how you name it overall. So that's a methyl group. This has 2 carbons, that's substituent. So that is an ethyl group. So that means that when I'm numbering the atoms inside of the ring, this is 1, this is 2, this is 3. So for this ring system, I need to number it counterclockwise, okay? If my methyl group was in the bottom vertex of my cyclic molecule, then I will be numbering the ring clockwise. So when it comes to this, as it was put in the chat, the name of this molecule is 1-ethyl, 2-methyl, and then I'm going to continue. Well, let me just rewrite it because it's all one word. 1-ethyl, 2-methyl, cyclopropane. Let's explore now, what about if we have 3 or more substituents? Understand, in this class, I give you guys up to 3 substituents in a ring system. So when you have 3 or more substituents, you're going to number the ring. Again, you can go in the clockwise directions or the counterclockwise direction. The important thing is that you're going to give the substituents in your ring the lowest set of numbers, and then you're going to list them in alphabetical order, okay? And we kind of learned a trick about this yesterday. Now, let's say that I go 1, 2, 3, 4, this direction, or I go 1, 2, 3, 4. Okay. I could have also gone and gone below, just because I see that specifically my substituents in both directions are going to be in 1 and 3. Okay. But the important thing, great job in the chat. You already got this. So when we have this scenario and we need to decide, okay, in the blue arrangement of numbers, I see that I will say that my substituents are, I have a methyl on 1, I have a ethyl on 1, and I have an isopropyl group on 3. In the magenta numbering, I have on number 1 my isopropyl group. On number 3, I have my methyl group. On number 3, I have my ethyl group. Okay. So for the answers that you guys see in the chat, the one that you're missing, Francisco, is putting cyclo. Don't forget it. This is our cyclic system. So taking this into account, I showed you guys a trick yesterday that I said, you know what? If you take these numbers and you add them, they will equal 7. If you add these numbers and you add them, it equals 5. The one that has the lowest value overall, that's going to be the correct numbering. So that means that specifically for this example, the magenta arrangement is not correct. The blue one is correct. And then we're going to write our substituents in alphabetical order. So who comes first? Methyl, ethyl, or isopropyl? Great, ethyl. So I say 1 ethyl. Who comes next? Great, the isopropyl. 3 isopropyl. The last one is going to be 1 methyl. And then the cyclobutane. Questions naming cyclic alkanes with 1, 2, or 3 substituents. Then let's go ahead and practice. So here we have some examples of cyclic alkanes, okay? So let's, in the chat, write the names. Let's do the first row together, okay? What would be the name of this molecule that I did the check mark on? What would be the name of that? Let's put it in the chat. Excellent. This is methyl cyclopropane. What would be the second molecule on the first row? There's an answer in the chat that has a number 1 for the methyl. We don't write number 1. Because when you only have one substituent in a cyclic system, you don't have to write a number. I agree with the propyl. There you go. The propyl, that is a cyclic heptane. Look, 1, 2, 3, 4, 5, 6, 7 carbon atoms in that cyclic system. So this is propyl, cycloheptane. What about the last one in the first row? What would be the name of that? Excellent. My substituent is an ethyl group. The ring system is a cyclohexane. Questions naming alkanes with one substituent or cyclic alkanes with one substituent. Those ones are pretty straightforward. Let's move to the bottom examples. The first two have 2 substituents. And then the last one has 3 substituents. So let's go through the first one on the second row. What would be the name of that? I agree with that name. 1 isopropyl, 2 methyl. And this is all one word. Sorry, it's just that in terms of space, I may have to write the next word below. Cyclobutane. Next one. What is the name of the next molecule? I see 1 ethyl, 2 methyl cyclopentane. Yep, I agree with that name. 1 ethyl, 2 methyl cyclopentane. Again, let me just write the numbering so people see where this comes from. If this is number 1, we're going to counterclockwise. 2, 3, 4. If we see the second example, my ethyl comes first alphabetically. So the carbon that is holding it is carbon 1. To give the other substituents the lowest number, you have to pick if you're going to count them clockwise or counterclockwise, but to make sure that the other substituents get the lowest number. So for that second example, this is carbon 2, 3, 4, 5. So we have to go clockwise. Yes, there is no dash between cyclo and alkane because that is one word. It's also between the last substituent and the parent chain. There's never a dash or hyphen. It's all one word. In the first one, I couldn't fit it straight, so that's why I wrote it below. Let's look at the last one. We have 3 substituents. There you go. Great job. Don't forget the cyclo. So this is carbon 1. This is 2, 3, 4, 5, 6. We just have to make sure that we give overall the lowest number to our substituents. So again, when it comes to this, I have 2 ethyl groups, and then I need to put them first because of the ethyl, not because of the prefix di, okay? So when it comes to this is 1, 4 diethyl 2 fluoro cyclohexane. Okay. Right now I'm making some extra problems for you guys in the chapter quiz. So you see how we deal with these naming problems in the exam. As I mentioned yesterday, the way that I format this question is that it's a drop-down menu. So you basically, generate the name on your end, and then from the drop-down menu, you select the numbering, and you select the prefix if needed, so on and so forth. Okay. If you already started seeing Lab 9, there are examples in Lab 9 of how these naming questions are actually formatted for exams. Any questions naming cyclic alkanes? Then let's move on to the next concept, which is talking about alkenes and alkynes. Yesterday, I introduced to you guys that alkenes and alkynes are also part of the hydrocarbon family. As we know, members of the hydrocarbon family are going to have hydrogen and carbon as the atoms that are present in those molecules. Now, when it comes to the general formula for alkenes, which are the ones that have one carbon-carbon double bond or more, or if you have alkynes, which is the chemical formulas that have, or the molecules, I should say, that have one or more carbon-carbon triple bonds, you can see the general formula equations there. For alkenes is CnH2n. For alkynes is CnH2n minus 2. So alkynes, because they have a triple bond, they're actually going to have 4 carbons less compared to an alkane. Now, when it comes to alkenes and alkynes, they are considered unsaturated hydrocarbons because they don't contain the maximum number of hydrogen atoms. Alkenes and alkynes are actually found in nature. I wanted to give you guys an example of an alkene that is found in tomatoes. So you can see in the image that we have on the right, this molecule is known as lycopene. Put a 1 in the chat if you have heard about lycopene before. You can actually get it as a supplement in like a pill form. Nobody has heard of lycopene before? Oh, one person has heard of lycopene. So lycopene is actually an important antioxidant. And lycopene, if you consume fruit and vegetables that are red in color, lycopene is one of those biomolecules that you will be consuming. Okay, now it has been suggested that lycopene is helps the body with dealing with molecules that create oxidation, but it also has been linked with health in terms of tissues, or like helping tissues to be healthier. So as you can see, the name of this molecule is lycopene. We see that in the name, it ends in "ene." When we look at the structure of it, what we see is a series of carbon-carbon double bonds. So the "ene" in the name comes from the idea that there's multiple carbon-carbon double bonds in the structure, okay? Tomatoes are among the fruits that have the highest amount of lycopene in them. And it actually, because of the properties of all these double bonds being present in the molecule, lycopene has also been associated with the red color, okay, in tomatoes, but also you can find like lycopene like in red peppers and stuff. But I just wanted to give you guys an example of an alkene that is actually found in nature. As we have done with alkanes and cyclic alkanes, the first thing that we're going to learn is how to name alkenes and alkynes. Let's get started with learning how to name alkenes. So when it comes to the steps, and as I mentioned to you guys yesterday, whenever we're dealing with functional groups, it doesn't matter if I have an alkane, an alkene, an alkyne, or like we were going to see later this week, alcohols, ketones, aldehydes, ether. We're always going to try to find the longest carbon chain, okay? Now, if you have an alkene, your longest carbon chain needs to include the carbon-carbon double bond. Now, you can choose to write the alkane name and you will remove the ending -ane, and because you have an alkene, you will now place the ending -ene in it. We're going to number the carbon atoms, as you can see in step number 2, from the end that is nearest a double bond. So again, when we have an alkene, now we have to focus on our carbon-carbon double bond. That is what needs to have the lowest number, okay? Then understand that if you happen to have an alkene that is equidistant, like the second example that we have here, we have to number it from the end that is nearest a substituent. But again, usually alkenes, we're going to number it to the end that is closest to the carbon-carbon double bond, okay? Now, when it comes to the name, the last word is going to be that prefix based on the number of carbons in the parent chain with the ending -ene. Then we need the location of the first carbon in the carbon-carbon double bond. And as a prefix of that, we are going to apply the rules that we already learned in chapter, earlier with alkanes in terms of the substituents, depending if you have one or multiple of the same, or you have different ones, okay? So let's just gather all of that information and try these examples. Let's go through the first molecule that we have here. So let's put in the chat, what is the number of carbons of the longest carbon chain that contains the carbon-carbon double bond? I agree with Marisol, there's 5. Thank you, Gia. Yep, there's 5. For those of you that are like, where are the 5? One, 2, 3, 4, 5. Okay. We need to start numbering from left to right because we need to give the carbon-carbon double bond the lowest number. So this is 1, 2, 3, 4, 5. Now, what is the prefix for when we have 5 carbons? What is the prefix? Great, pent. And because it is an alkene, is pentene. The alkane name will be pentane, but because it is an alkene, is pentene. So again, when it comes to naming my parent chain, these are my 5 carbons. Pent, because we have 5 carbons. Ene, because we have an alkene. Yeah, almost like the shampoo. Yeah, Pantene actually has alkenes in the molecules for the soap. It actually has pantothenic acid, which it has alkenes in it. Now you guys are going to be like, is it in because it has an alkene? You will see, you will be surprised. When people come up with the name for certain products, it's just based on the chemical formula of the product. So, so Pantene is the name of our parent chain. Let me highlight it for the students that need extra assistance in following. So that's why it's Pantene. Now, before the Pantene, I need to we need to give the location of the first carbon in the carbon-carbon double bond. So I will put 2 Pantene to symbolize that this is the first carbon in the carbon-carbon double bond. Okay? Now, how many substituents do I have in this molecule? Let's see if we remember. How many substituents do I have? Great job in the chat. We have 2 of them, and they're both methyls, so that's why it's called dimethyl. Great job, Marisol. It's dimethyl, and because I have a dimethyl, I need to get their locations. 2, 4. Okay. So for those students that are like, I don't see it, this is a methyl group, this is a methyl group. Actually, put a 1 in the chat if you want me to write in the carbons, because I know that this is recent. We barely learned about skeletal versus condensed. Put a 1 in the chat if you want me to write in the carbons here, because I know it may help some of you. Okay, so this is a CH3. This is a carbon. This is a CH3. This is a CH. This is a CH. CH3. CH3. So as you can see, the ones that I circle in orange, those are the positions of my methyl groups. And then the dimethyl are the 2 CH3s that are out of that. Yeah, you guys are correct in the chat. The 2 before the pentene is the first carbon in the carbon-carbon double bond. For alkenes, you need to tell me where's the first carbon in the carbon-carbon double bond. As long as you have 4 carbons or more in your alkene, you have to tell me where does the carbon-carbon double bond starts. Okay, let's move on to the next example. In the next example, okay, I have this as my longest carbon chain. And let me illustrate to you guys why is it that we call this alkene equidistant or equidistant. Okay, so let me number my alkene. This is carbon 1, 2, 3, 4, 5, 6. Well, I can number this 1, 2, 3, 4, 5, 6. What makes this alkene equidistant or equidistant is that in any of the 2 directions that I'm numbering that carbon chain, My alkene is always in between the same two digits. In this case, it's going to be between carbons 3 and 4. Put a 1 in the chat if the concept of equidistance makes sense. Again, for the students that didn't catch it, equidistance means that when I number my longest carbon chain in either direction, where that longest carbon chain is located, my carbon-carbon double bond is going to be in between the same two numbers. In this case is 3 and 4. Now, when it comes to this now, as you can see in rule number 2, the correct numbering is the one that is going to begin nearest the ends to the closest first substituent. So what's going to be my correct numbering, the blue one or the red one? Excellent. I agree with the people that are in team red. Your first substituent is, as you can see, you can give this a number 1. The fluorine can get a number 1. So you're comparing the substituents 2 and 6 in the blue arrangement or versus 1 and 5. Okay, so the red is the correct numbering. Now let's set up the name for this alkene. What is the name of my parent chain? 6 carbons and I have an alkene. Great job. Hexene. Hex means 6. Ene because of the alkene. What number do I put before my hexene? Where is my first carbon in my carbon-carbon double bond? Great. Now, as a prefix of that, I need to put my substituents. I have different substituents. Which one comes first, the fluoro or the methyl? Great job. 1 fluoro, then the methyl, 5 methyl, 3 hexene. Okay. Questions, naming alkenes. One more thing about alkenes, you guys. Alkenes can be cyclic. Okay. Now, as you can see, when we have alkenes that are cyclic, your carbon-carbon double bond in the ring system is always going to be between carbons 1 and 2. Always, you guys. Okay. So you have to make sure that the 2 carbons in the carbon-carbon double bonds get number 1 and number 2 position. Then you're going to number the ring clockwise or counterclockwise to give the substituents the lowest possible number. And then, as we have done before, the last word is going to be the name of my cyclic alkene. As a prefix of that, I need to give the location and the name of the substituent. So even if you have one substituent in a cyclic alkene, you have to tell me where it is. So let's go through the example, the first example that we have. So based on the shape that this has, in the rules that we already learned, this is a 5-carbon cyclic alkene. What would you guys think will be the name of this parent chain, which is the cyclic system? It has 5 carbons and it is a cyclic alkene. Great job. That is cyclopentene. Now, as I mentioned to you guys, my carbon-carbon double bond and my cyclic alkene need to be between 1 and 2. So when I number this, I'm going to do 1, 2, 3, 4, 5. Or I can do, oh, let me write these numbers outside. It'll be easier. Or this can be 1, 2, 3, 4, 5. Which color is correct? Great job, any of the two. Great job, you guys, you're getting the hang of it. So I'm just gonna keep the green one. Great job in the chat too with the name. So I need to put the location of my substituent, which is on carbon 4. And then I'm going to write the name of my substituent, methyl. And then the next word is cyclopentene. We don't need to put a 1 because it is known that in a cyclic alkene, your carbon-carbon double bond is between 1 and 2. Okay? Let's move on to this example. So if I'm numbering the ring system, I can select 1, 2, 3, 4, or I can do 1, 2, 3, 4. Okay. So in the magenta arrangement, I'm going to have 1 bromo, 3 ethyl. In the purple one, I will have 2 bromo, 4 ethyl. Okay. Remember that the rule is that my carbon-carbon double bond in the alkene must be between 1 and 2. Always in a cyclic alkene. Now, based on the rules that we already discussed in terms of numbering the substituents, you guys, which one would you pick? Magenta or purple, or you can say pink or purple. Great, magenta, I agree. For those students that are like, okay, why magenta and not purple? Remember the trick that I showed you guys. You add these two numbers, this equals a 4. We add these two numbers, this equals a 6. This has the lowest value. That means the lowest number for my substituent, so that will be the correct numbering. So when we are naming this, okay, what is the last word, the name of my cyclic alkene? What would it be, you guys? I have 4 carbons and it's an alkene. Great job. Cyclobutene. Remember, no number for the cyclic alkenes. And then, as you can see, my substituents already have the numbers. Which one comes first? Great, the bromo. Great job with the name in the chat. This is 1 bromo, 3 ethyl, cyclobutene. Okay. Any questions on alkenes or cyclic alkenes? Put a 1 in the chat if you're ready to practice going from name to structure, structures to name. We're going to start with structure to name. Great. Let's practice. Okay. On the top, we have regular alkenes. In the bottom, we have cyclic ones. So after we go from from structure to name, we're going to go from name to structure. Okay. So let's do these as a group. You guys are pros at this. Next week, that exam, I'm telling you, you guys are going to excel. We're going to make that average go up. So find the longest carbon chain. What would be the last word in this alkene? I'm looking for the name of the parent chain on this alkene. I agree with the butene. 4 carbons. Butene. Okay. Now, we only have 4 carbons. Does it matter if I number it left to right or right to left? Let's say yes or no. Ooh, I agree with Francisco and the people that changed their minds. So in this one, it doesn't matter because your 2 substituents are always going to be between carbons 1 and 2. Let me illustrate it. If this is 1, this is 2, this is 3, and this is 4. And this is 1, 2, 3, 4. This is what we called an equidistant alkene. Okay? Now, in this one, it doesn't matter, right to left or left to right. So before the butene, I need to give the location for the first carbon in the carbon-carbon double bond. So let me just erase this. We only need 1 set of numbers. What number do I put before my butene to give the location of the alkene in the butene? Great, I need a 2. Then I have 2 of the same substituent. So what word should I use? Great, the dimethyl. And then we have the location. I have to, if there's a di, I need to give 2 numbers, a 2 and a 3. Okay. Let's move on to the next example of a straight chain alkene. How many carbons in my parent chain? Excellent job, you guys. You're getting the hang of it. So what would be the name of that parent chain? Great job. Now, which way should I number it? Ooh, great job. People are already on top of it. 1, 2, 3, 4, 5. Because remember, in an alkene, we need to make sure that the carbon-carbon double bond has the lowest number, not the substituents, unless we have an equidistant alkene. So remember those little rules. So we are numbering this way. So what number do I place before the pentene to give the location of the first carbon in the carbon-carbon double bond? Great, 2 pentene. We have 2 substituents here. Very similar to the previous problem. Excellent. Don't forget the di in dimethyl. Dimethyl. In those 2 methyls, one is in carbon 2, the other one is in carbon 4. Okay? Make sure that you practice. There's way more problems than this. in the in-class worksheet. Questions about alkenes before we move on to the cyclic ones? Then let's move on to the cyclic ones. Let's look at the first one. Great job in the chat coming up with those names. So my parent chain is a cyclopentene. To make sure that my substituent get the lowest number, after I number as 1 and 2 my carbon-carbon double bond, I'm going to go 1, 2, 3, 4, 5. So in position 3, I have a bromine. Okay? Remember, there's no dash between bromo and cyclopentene. I stopped making students type the answers. I actually do a drop-down menu when it comes to these. It's much better for you guys and for me. Let's move on to the next one. Two substituents. What is the name of the parent cycloalkene? Yes, you're correct. Don't forget your cyclo, you guys. I like those hexenes, but we need to put cyclo before. So yes, we have to, in this case, go counterclockwise because the substituent in the cyclic alkene needs to be the lowest number. If we go into the other direction, it will get a number of 5. It's just that in this direction, it will get a number of 3. Let me show that really quick. If we go 1, 2, 3, 4, 5. Bromo shouldn't be a 5 when it can be a 3. So going back to this example, our longest parent chain is a cyclohexene. Okay. When we do the numbering, in this case, we have to go counterclockwise. 1, 2, 3, 4, 5, 6. So on carbon number 1, we have a chloro group. On carbon number 3, we have an isopropyl group. Questions on naming alkenes or cyclic alkenes? And with an ox practice, you guys, you know, these, like you'll be able to look at a molecule and then just go straight into numbering because it becomes familiar. You know, after a while you see the shapes and then you know, specifically for the cyclic ones, once you know your geometric, you know, structures, once you get to 8, 9, and 10, those you have to count just because the shape that they adopt is going to be a little bit funky. But the more you practice, these are going to become less difficult. Let's now practice, if you're given the name, how to draw the condensed structure and the skeletal structure for a given name, okay? Let's go through the first one. We have 3-ethyl 1-pentene, okay? As I told you guys, if you're given a name, you should start writing the parent chain first, okay? So if I have a pentene, how many carbons do I have for a pentene? Great. We got 5 in a row. So if I'm drawing my condensed structure, I'm going to go 1, 2, 3, 4, 5. Okay. Where is the carbon-carbon double bond? In between which 2 carbons? Great. 1 and 2. That's exactly where I'm going to write it. If this is 1, this is 2, this is 3, this is 4, this is 5. Okay. Then I see that I have a substituent on carbon number 3, is an ethyl group. Remember that the ethyl group, you attach it through the CH2. So it's a CH2 attached to a CH3. We never attach an ethyl through the CH3. It's always through the CH2. Now that I put in all of the components, I'm going to write in the hydrogens, okay? How many hydrogens does carbon number 1 get? Great job. 2. How many hydrogens does carbon number 2 get? Awesome. Carbon number 3. Awesome. You guys are getting the hang of it. Carbon number 4. And carbon number 5. Excellent. So that's your condensed structure. Let's go to the skeletal. So as I mentioned to you guys for Chemistry 104, I do not mind if you guys do the circles, but you guys are not going to be submitting any work to me. Just understand that when you're writing out your structures, it is okay to have those hard circles to illustrate the carbons. So if this is carbon 1, up carbon 2, down carbon 3, up carbon 4, down carbon 5. Okay. My carbon-carbon double bond, specifically for those students that may have to take organic chemistry, you know, partially only 1 semester or a full year of organic chemistry. Understand that these hard circles, my colleagues that teach those courses do not like them. Now, when it comes to the carbon-carbon double bond, understand that we need to commit our line between carbons 1 and 2. Why do I mention this? Because I may have some of you that have to take organic chemistry the full year or at least 1 semester, depending on your transfer program. If you give a half line, meaning if you say like, oh, this is the double bond. In organic chemistry, that means that here there's another carbon. So be mindful in the future that when you are drawing a double bond, draw it whole. Don't run out of ink. And if you run out of ink, get another pen. For this molecule, it doesn't matter where we put the carbon-carbon double bond. What I ask students, like especially now in the fall, when I go back to face-to-face, is that they keep consistency in the molecule that they do in the condensed versus the skeletal. So since I wrote carbons 1 and 2 to the left, then you keep them there. But if you decide to do it from the other corner, that's okay also, because it's relative. Oh, yeah, top, underneath, doesn't matter. I just need to see another line between carbons 1 and 2. For me, it's just in practice, in my years of training as a chemist, I always put it above. But if you put it below, it's okay too. Doesn't matter. Then on carbon number 3, see how carbon number 3 is the vertex pointing down? So when it comes to the logistics of organic chemistry, if you have a vertex pointing down, that means that the substituents will also be pointing down. So my CH2, CH3 has to be going here, here, because the vertex where I have carbon number 3 is pointing down. Again, for students in Chemistry 104, if they write the ethyl group pointing up, I don't care. But for the students, because I actually teach organic chemistry, I will start fall of 2023, actually, teaching organic chemistry. Like, I make students write the correct molecule. So I want you guys to have good practices, especially for those students that need to take all their organic chemistry. That's a great question, Yesenia. If you make your skeletal structure look like a W, that's also correct. That's the beauty of organic chemistry, that this is the only artistic thing that I know how to do in my life, draw molecules. So if you would have said, hey, this is carbon 1, down carbon 2, up carbon 3, down carbon 4, up carbon 5, and you say, hey, this is my carbon-carbon double bond, and this is my ethyl group, this is still correct. That molecule that I drew on red is just flipping 180 degrees, okay, clockwise, the molecule that I wrote in black. It is the same thing. Questions about the first one? Yeah, you can rotate it in any way. Trust me. When I was an undergrad, and even through my grad school years, because my PhD is actually in organic chemistry, professors will make these molecules and flip them in any way. And that's one of the things that I find that many people that study organic chemistry, like me and like some of my colleagues, that's what makes it difficult for some people. I was like, oh my God, organic chemistry is so bad. I don't know. I think we have an innate ability to look at molecules and flip them 3D. I know I do. So if you flip any of these molecules 90 degrees, so for example, if you are in an exam, and I guess as a student, if you want to make your professor mad because you're making them think through the process, if you drew this, that's also correct. It's just for them, they have to figure it out. For me, I'm just giving you guys the short version of it. But then again, if you have to take organic chemistry at least one semester or the full year, because that's part of your degree program, understand that molecules are not static, molecules move, and sometimes professors really enjoy to trick the brain of students by drawing these molecules all crazy. For me, I just want you guys to understand how to go from words to draw these molecules condensed or skeletal. For me in this course, when it comes to this is a multiple choice question in which I give you the name and then I give you different structures. And you need to be able to know how to relate that name to the structures that you have and pick the correct one. Sometimes the structures are skeletal, sometimes the structures are condensed. At least for online learning. If it's face-to-face, students need to draw this. Let's go to the next one. 2-bromo-3-methyl-1-butene. Butene, how many carbons in my parent chain? Great, 4 carbons. 1, 2, 3, 4. Where's my carbon-carbon double bond? Great, between 1 and 2. So this is why it's so important to have those numbers. So I'm trying to show you, like, the name tells you the structure. Then we have 2 substituents. For me, it's always easier to do left to right when I'm drawing a molecule. And then on carbon 2, we have a bromine. On carbon 3, I have a methyl. Now, let me warn you, the reason why I decided to put the bromine up and the methyl down is for just space issues. If you draw the methyl up, it's still correct. Okay. Now let's actually include the hydrogens in our condensed structure. How many hydrogens does carbon number 1 get? Awesome. How many hydrogens on carbon number 2? Great job, none. What about carbon number 3? Carbon number 4? Excellent, you guys got this. I also ask a question in exams. I give you basically like a naked molecule, meaning just the carbon atoms connected by bonds. And then I put a star next to a carbon and I tell you how many hydrogens are on the carbon that has the star. And it is important that you guys know how to assign these hydrogens. You don't want to miss those points in the exam. Then let's do the skeletal. We have 4 carbon atoms. 1, 2, 3, 4. My carbon-carbon double bond is in between 1 and 2. Again, Br is going to be pointing up because carbon number 2 is in the vertex up. Methyl is pointing down, okay? Because on carbon number 3 is down. Now, let me warn you, especially for the students that are taking other courses in organic chemistry, technically that CH3 you don't write in your skeletal. Skeletal is only for atoms. So the only atoms that you write are things that are other than carbons and hydrogens. And the only time you write in hydrogen if it is bonded to something else. Like hydrogen is bonded to oxygen in an OH group for an alcohol, then you write in the hydrogen. But any carbon or hydrogen attached to carbon, you don't write in the skeletal. Oh, I didn't draw the star. This is what I mean with the question that I do in the, I will do it with the next one. What I mean with this. Any questions about the second one? Then let's move on to the third. We have cyclohexene. You can put in the double bond wherever your heart desires. Let's say that I put it here. Okay. Now, because we have the condensed structure, I need to include the carbons. Okay. So there's a carbon right here. There's a carbon right here. 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 Okay. I have methyl groups on 1 and 6. Okay. That's number 1, 2, 3, 4, 5, 6. Okay. So let's say that I have a carbon right here, carbon right here. Okay. So what I was saying, for example, is that let's say that I have this molecule and I ask you guys in the exam, let's say that I put an asterisk here. And then the question will be, how many hydrogens does the carbon with the asterisk need in order to complete its octet? So if I give you several of those molecules, you need to assign the hydrogens in it. That is a numerical entry question. So how many hydrogens does the one with the asterisk mean? Exactly, it needs 0. So what you will answer is a 0. So this is what I mean with a naked molecule, okay? So because we're dealing with a cyclic molecule, okay? Let's just put in the hydrogens. This is a CH3, this is a CH3, CH2, CH2, CH, I put 2 extra carbons. H2, H2, those are the only ones that get hydrogens, okay? The skeletal structure of this is this molecule, okay? Now, I want to bring up something about this problem, okay? And the reason why I'm bringing it up is because of lab 9. You guys have 2 problems in lab 9. Go ahead, Marisol, what's your question?
So I'm still trying to, when we put in the methyls, since it's 1 and 6, I first guessed that the bottom left one, that would be 1. Wait, well, because the double bond has to be on 1 and 2, correct?
Yes.
So 1, 2, 3, 4, 5, 6. So that's why I thought that the second methyl would be on like either before or after the double bond. Because wouldn't that make it 1, 2 dimethyl?
And
The
that's
one that,
exactly what I'm going to explain now, because in
okay,
lab
okay.
9, you guys have problems that have the following problem that you just stated. So thank you for bringing
Okay,
it up. That's exactly what I'm going to go into.
okay, thank you.
So in lab 9, you guys actually have 2 questions, okay? Or 1 question, but there's 2 problems in which the problem reads, the following name is incorrect. Like it will say that the following name is incorrect. With the incorrect name, draw the molecule, just like we did right now, okay? With the incorrect name, we drew a molecule, okay, which results in this. And just like Marisol was pointing out, but wait, professor, if this is 1 and 6, and based on the rules that we have done, if this is 1, then the person that was naming this and named it incorrectly assumed that this is 2, 3, 4, 5, and 6, okay? And it said, okay, great, 1 and 6. Again, this is because somebody named it incorrectly. We drew the structure name on that incorrect name. Now, just like Marisol was pointing out, but wait, that name is not correct. The name of this molecule correctly will be what she just mentioned. Wait a minute, no, it's not 1 and 6. It is actually 1, 2 dimethyl cyclohexene. Okay, so understand, but then I don't understand how you would draw it differently. If you do 1, 2, 3, 4, 5, 6. You guys drew this? Okay. And that's the correct structure for it. I just wanted to point out that there's questions like that in the lab. I should give you an actual problem of like incorrect name. So let me just fix this molecule. Give me one moment, you guys. Let me give you an actual problem that will help you with the lab. So let me redraw it with the correct one. So this is what you guys got. So then that means that in your skeletal, is this. Excellent. So what I drew before was the 1, 2. This is the 1, 6. But let me give you guys one of those problems. Well, actually, it's 10:22. I'll do it after we come from break. So you guys can practice for the lab. Because I know in lab 9, you guys have problems like this. So yeah, the molecule that I drew was the 1, 2. This is the correct 1, 6. But I'll give you guys, so sorry that I drew the wrong molecule. I drew the 1, 2, not the 1, 6. But I'll give you guys problems in which the name is incorrect, and then you have to draw the molecule based on the incorrect name. And I think in the worksheet, I actually put, there's one problem in the worksheet of incorrect name, but I actually labeled it, hey, this name is wrong. So thank you for catching that. Questions, going from name to structures. Great. Then right now, let's go on break. Right now it's 9:23 or 9:23, 10:23.